Now we will talk about simultaneous equations, which will be the next part, after talking about linear equations and quadratic equations. Alright, so now we'll talk about simultaneous equations, but it'll only be limited to linear equations. So everything that we've talked about in linear equations will apply under simultaneous equations. But we do something, and we mention something that is very important that will enable us to solve much more complicated problems in maths. We can solve simultaneous equations in many ways. However, we will discuss three ways: solving by substitution, solving by elimination, and graphically. Yet again, I hope you're seeing by now the word graphically, meaning that we come from functions. The solutions come from functions. So we have to understand functions, because you can see how many sections this idea lends itself to. See, solving by substitution and solving by elimination are basically using algebraic methods to solve. But solving graphically comes from the whole idea of functions. This is why, and this is the section that proves the importance of functions. Understood? We call these equations systems. We will deal with linear systems, which comprises of two equations and two unknowns, right? So let's say, for example, you're given y is equal to 2x plus 1, and you're given y is equal to 4x minus 2. This is what we call a system of linear equations. And the most important rule is that you require the same number of equations as they are unknowns. If I look at this linear equation, how many unknowns do I have? Unknowns mean how many variables do I have? I have 1 and 2. In this question, how many do I have? I have 1 and 2. So therefore, since I have two unknowns, I require two equations. This is a very important rule for simultaneous equations. Two unknowns and two equations. If you have three unknowns, then you require three equations, and so on. A solution to the system is simply a x and y value that will satisfy both equations. So basically what we're saying is, once we solve for the system, we'll get some value for x and we'll get some value for y. When you take this x value and you input it into this equation, and you take that y value and input it into that equation, you should have left hand side equal to right hand side. That is what we are doing. And the same applies if you take that exact same y value and you take that exact same x value, you should get left hand side equal to right hand side. This is why we say simultaneous equations. You need to solve this equation and that equation simultaneously. So what solution will satisfy both that equation and that equation? Okay, now this is a very important idea, because this is something that I didn't actually talk about when we did linear equations. So let me remind you again, right? When you're solving linear equations, as we've talked about in the previous section, right? How to the linear equations, grade 10 linear equations, you're just following the BODMAS and using the additive inverse. Now, simultaneous equations, you're employing the exact same ideas. But now we're saying that if you're given two unknowns with linear equations, how do you solve them? And this is why I said that they apply for much more complicated examples. And this is a very, very important point. You may yield three types of solutions. You may yield no solution. This means that the linear functions are parallel and the lines are not collinear. So this means that the linear functions are parallel and the lines are not collinear. If I have to draw, you would have done line functions at grade 9. If I have to draw the line function, you have one line function here and you have another line function here. These line functions are parallel. What does it mean for something to be parallel? It means it is equidistant and it will never touch. That's what it means. So even if I go, however far I go up that way, it will never touch. It'll be the same distance. So this is what happens if I gave you an equation here and I gave you an equation for this function here and I told you to solve. So let's say I said y is equal to 2x and here I said y is equal to 2x minus 4. If you solve for these two equations simultaneously, you'll have no solution. And it makes sense, because what x and y value can I put in here and x and y value that I can put in here that both these functions have in common? That is what we are saying. What x and y value do both this function and that function have in common? They have none, because they're not touching at any point. Right? That's a bit more of a higher order thinking. Right? So that's the first one. The second one solution. This means that the function only intersects at one point. So if I have something like this, and if I had a function go like that, then this will be the solution to these equations, because that's the point, that's the x and the y value that both this function and this function have in common. So that's the solution that will satisfy both the equations simultaneously. And the third type of question, right, remember, just take this down. I will explain this once we get to functions. For now, just write this down so you have all of your notes in order, right? Let's say that you have this here. Let's say that you have this. I promise, after we get to term 2, I will come back to all of this and give you a very brief introduction into all of these ideas, but please take it down now. Let's say you have a function that looks like this here, right? And then you have another function that sits directly on top of it. So they are collinear. That's what we say. We say they are collinear, meaning that they lie on top of one another. For something to be not collinear means they're not touching at all. For something to be collinear, meaning that it coincides, it's collinear, right? They lie one on top of the other. For this question, you have infinitely many solutions, meaning that there's every x and y value that could possibly exist will satisfy both equations. Every possible x and y value will satisfy both equations. What I just taught you here was the 3 possibilities that you could get, and this third possibility will not be examinable at secondary school. So I basically taught you university work at grade 10. Okay, so the first 2 is what we have to look out for, the one solution and the no solution. And the last one is something that we'll talk about at university. Understood? But now you have a complete list of possibilities that you should expect when working with linear equations.